Really?
I had it with theater.
Mm-hmm.
Even can't really see it.
Just come to class then.
Yeah.
Okay.
What is
Zoom, I'm going to talk to you. You just get logged in. Well, not really. Not the way I do it. It's different. Zoom recording. Okay. So we are starting in chapter 3, which is graphing. I'll go ahead and warn you, Chris, I'm left-handed. I'm going to be standing on this side. Yeah. Yeah, no, that's fine. I would sit right over here. Yeah, you definitely want to be on this side, though. Yeah. Okay. Chapter 3, we are on graphing linear equations on page 169. Yeah, most of the time when I write, I am going to be here writing writing yeah, typically left-handed, so writing this way, standing on this side, and that just gets blocked on this side and warning you. Okay, graphing linear equations. First off, plotting ordered pair on a rectangular coordinate system. The rectangular coordinate system, also called the Cartesian plane, is basically a number line, which would be straight because it is a line. It goes in both directions. The middle number, our starting point, is 0. Numbers going to the right are positive numbers. And they go forever. From the 0 going left are negative numbers, and they go also forever. Right? Okay. I can plot any number, any singular number on a number line. I want to plot 3. All right, there's 3. I want to plot 2.5. Well, 2.5 is in between 2 and 3, halfway. Okay. But to graph equations, and equations have 2. We need another number line. This number line here is going to be our x-axis. And x values get plotted on the x-axis. I need another number line for y values. So we're going to draw another number line on top of this one. So we're going to put this one vertically. So we're going to put this one vertically. I think it's 0 is still our starting point. 0 is where we cross the x-axis. Right here, it's 0, 0, same point here. And numbers going up are positive. And they go on forever. Numbers going down are negative. And they go down forever. Okay. As far as plotting a point, since I do have x's and y's, x coordinates and y coordinates, and we do need to be able to plot these somehow. Let's say I have this point right here. which is right 3 and up 1. I need a way of labeling this. And so we label it with what we call an ordered pair. In which the x value is always first. So this would be the point 3, 1. There's a parentheses around it, and it has a comma in between separating the two numbers. You could just as easily label a negative number. Like this one here goes left 3. That's the x value is negative 3. And the y value is positive 2. So negative 3, 2. Coordinates going down are negative. So this one went right 5. That's positive 5. That's the x value. Or 4, sorry. Right 4. And it went down 2, which is negative 2 on the y coordinate. So 4, negative. To plot any point on the Cartesian plane. Some points fall directly on an axis. This point right here. How far left or right did we go? We went left or right 0. How far up did we go? 4. Oh. So directly on the y-axis. This point would be what we would consider a y-intercept, meaning is where we cross or where we touch the y-axis. Okay, is where we touch the y-axis with the y-intercept. If it's where we touch the x-axis, then it's considered an x-intercept. An x-intercept is where we cross the x-axis. Questions about plotting points. Okay. All these points, all these numbers, these ordered pair, are not only points on a they can be the solutions to equations. Okay, so if I give you an equation, three x minus y equals 12. Is this a solution or is this not a solution? Well, the only way to know is to simply plug it in and see if it works. Three, 1. Is this a solution? Well, let's plug it in and see. What is the x value? 3, right? The first one's x, second one's y. Okay. So the x value is 3. No. Not a solution. Okay, that is not a solution. Okay, fine. No big deal. Let's see if we can find, just check another one. How about 5/3? Let's check. Oh, 5-3 works. You want just kind of help us out here? That one didn't work. Okay. Right, 5-3, that's the solution. 12 equals 12, true. Okay. How about, well, 4-0. It is. Right? Plug it in, 3 times 4. Oh, yeah, 4-0 is a solution. That's great. We're good with that. How about 2, 3? 2 negative 3. How about 2 negative 3? No. Yeah, 9. 9. That's not it. Well, you can't. There's an infinite number of solutions. So how many solutions are there? Infinite. We'd never be able to write them all out, which is why we graph. So, to answer your question, technically yes, because we're going to draw the graph. But yeah, not a solution. How many solutions are there? There's an infinite number of solutions. 2 negative 6. 2 negative 6 seems reasonable. Yeah, 2 negative 6. Solution. Okay. Well, how do I come up with these solutions? I don't just randomly guess them, right? We could, but that's going to be. Okay. These are solutions. If I want to graph an equation, what I need a set of solutions. Probably, and normally we try to get at least 3. With a straight line, you can really do it with 2. So if I want to graph this, what I'm going to do is I'm going to graph these points. I have 3 solutions. 5, 3, 4, 0, 2, negative 6. We are going to draw the Cartesian plane. You want these to be reasonably well spaced, evenly spaced. Doesn't have to be perfect, but you will notice discrepancies if you're off. I want to graph these 3 points. 5, 3. Right 5, up 3. Zero. 2, negative 6. We're going to draw a line through them. It should be a straight line, really relatively straight. You can fudge a little bit just to get your points a little bigger, but should be a straight line. Should be a straight line. Now, here's something I want to point out. Every single spot on this line is a solution to the equation. Single spot is a solution to the equation. Three negative 3 is a solution. Okay, 3 negative 3 is a solution to that equation. This one's not obvious, but it is a solution to that equation. This is 11/3 negative 1. It's a solution to that equation. Okay, is a solution to that equation. I can plug that in to the equation. It would work. Every single point on this line is a solution to the equation. That's what a graph of a line is. It is a visual representation of every single solution. Fractions, decimals, irrational numbers. Every single solution on that line is, every single spot on that line is a solution to the equation. We can check one for 11/3 negative 1. Three times 11/3? 33. Oh, it works. For graph, we need 3 points. So I'm not just going to randomly guess numbers. Okay, we are not going to randomly guess. Two y minus 5x equals t. What we are going to do instead is we are going to pick a number for either x or y. Plug it in and solve for the corresponding solution. Pick a number. Relatively small, hopefully. 2. What do you want to be 2? You want x or y? Y to be 2. So we have chosen for our y to be 2. Which means we are going to plug that in and solve for x. Two times 2 is 4. Get by itself, how? Subtract 4 from both sides. Negative 5x equals 6. Divide by negative 5 on both sides. X equals negative 6/5. I would leave it -6/5. That's just a personal preference. So you can do whatever you want. If you want to do -1.2, that's fine. Nobody cares. This is just a decimal. As long as you do not round. Do not round. -6/5 is exactly -1.2. Didn't have to round it to get to that. Okay. But normally, first fractions. -6/5. That's not a very nice answer, but that's okay. We'll deal with it. How about another one? I need two more. I need two more. Pick another number. 4 for the y. Okay. So we have chosen y to be 4. 2 times 4. That's 8 minus 5x equals 10. Subtract 8 from both sides. Divide both sides by -5. X equals -2/5. Okay. Oh, besides just randomly guessing numbers, this is the way we're doing it. We're not randomly guessing numbers, ever. Yeah, randomly guessing numbers is a bad method. We will never, ever use. Mm-hmm. Oh, we didn't have an X or a Y, though. Uh-huh. So I plugged into both of them. I had both an X and a Y given to me. 5, 3 were both given to me. I had both X and Y. So whenever I plug those in, right, when I plug in 5, 3, there are no X or Y's to solve for. Right? I can't solve for X or Y because there is no X or Y. But here, when I plug in, I only have one of the variables given. Actually, none were given. I'm just throwing one in there. I'm making one up. Said y equals 4. I said, okay, cool. Y equals 4 seems perfectly reasonable. Plug it in. Not in front of them. They are both. If X and Y are both given, then you plug them both in. Here, X and Y were both given. X equals 5, Y equals 3. So I plug them both in and see if it works. Here, so we just make one up. We were 5, 3. I give you those. Those are given to you. We are equaling 10. So hold on. We are equaling 10. -6/5 2 equals 10. Well, I'll plug that in. Yes.
To figure it out. This one here was trying to figure out the next one.
Yes.
Oh, so
yes. I give you the numbers and ask, do these work? Right. But here, I'm not giving you anything. I'm just saying, you give me some numbers that work. So, There is a corresponding number that goes with it. Yes. Yes. Yep. Mm-hmm. Yep. If I plugged in 58, you're going to get a number, but you don't want to do 58. Yeah. Yeah, that's, let's make it the Y. Yeah, yeah. The problem with 58 is what? No, I mean, the solving is not hard. Solving is easy, actually. What's the problem? One problem is I got to draw 58 dashes on my graph, which is, that's what I don't want to do. 58 times 2. Subtract 116. Divide both sides by -5. $21.2. Yeah, here's the problem with that. You need a really big graph to do that, right? 21.2, 58. Has to go right 21.2, up 58. Yeah, we try to keep the numbers relatively small. We try to keep the numbers relatively. You have. Oh, give me an X. We're not going to use that one. We're going to throw that one out. 6. Y equals 6. Or X equals 6. Okay. This is a bit, 6 is a much bigger number than I would like also, but it will work. So how do I solve for Y? Add 30 to both sides. Two Y equals 40. Divide both sides by 2. But I don't want to graph 620 also. It's really high. Plug in a smaller number for X. Let's plug in -3. Okay. I have no problem with -3. No, it's fine. I'm going to plug in -3 for X. But the point is, I can plug in any number. It will give me a solution. Plugging in -3 for X. Okay. -5 times -3. Plus 15. 2Y plus 15. Subtract 15 from both sides. Y equals -5. Divide by 2. Get Y by itself. Y equals -5 halves. Yeah, let's draw this graph. We have 3 points I think that are acceptable. Stretch too far to get them. I don't like the fact that they're all fractions, but we're going to talk about that in a minute. Let's draw our graph. I'm going to go ahead and just erase all our work here. Very tediously draw this Cartesian plane. Okay. And I'm not going to go any higher than 4 because none of our numbers go higher than 4. So I'm going to make these relatively large also. Because I have fractions, I need to put in between here. Okay, let's graph these 3 points. -1, they're -6/5, 2. -2/5, 4. -2/5, 4. Okay, so -0.4. -0.5. Does it look like these will make a straight line? Yeah. Kinda. I might make a straight line out of them. Well, it does look interesting. You know what? Let's see if I can just turn that a little and get it in there. Okay. Oh, no. I was excited there for a minute. I had it. Yeah, okay. We're going to go with that. My real problem is my own inaccuracies of drawing a graph, right? The real problem. You know what? We can just, yeah, hit them. Got it. Okay. Yeah, no, that's the real problem. The real problem with drawing these by hand is trying to do this. Now, what's the problem? What's the problem with these points? The fractions. I don't like the fractions. Okay, the fractions are a problem. The real problem is trying to do these fractions out here in the middle of nowhere. If I was doing this to, instead of just randomly picking numbers, always work, by the way. And it is not a technique we're going to abandon. That's a technique we're still going to use in college algebra sometimes. If you need to draw a more accurate graph, then you need to plot more points. Okay. You can. I don't bother, but it can't hurt. We're still going to have inaccuracies drawing graphs. It just, we will. Mm-hmm. Yeah, you have the order. Well, okay. Your graph can look terrible. You know that this is going to be -3, -5 halves. Because it's obviously not. Yeah. Um, huh? Ruler. Yeah. It doesn't have to be perfect. where you're going. It helps. Yeah. Yeah. There you go. What was that equation? It was 2y minus 5x equals 10. No, it depends. I haven't made tests. It'll be on the left-hand side. It'll be like your videos tab. Yeah, 3 blackboards. It'll prompt you to do so. I don't think she did you have people in class? Okay, so maybe instead of trying to find these points, these fractions, maybe it'd be easier if I don't have to worry about going left and right and up and down. So what we're going to look for, we're going to look for intercepts. Intercept. If I'm looking for an x-intercept, how far left or right did I go? I don't. How far up or down did this go? Always 0, right? It doesn't matter where the intercept is. Okay, so to find the x-intercept, this is the rule from here and x-intercept on the Cartesian plane. First, solve for x. Okay, set y equal to 0, solve for x. There's only 2 rules. This is the rule for finding y-intercept, x-intercept, finding x-intercept. Now for set y equal to 0, solve for x. I probably asked this question on every test in college algebra. Find the x-intercept. Set y equal to 0, solve for x. Now, solving for x can get harder than what we're about to do. But this is a question set. Y equal to 0, solve for x. Okay. Let's do that. So y let's find the x-intercept. Set y equal to 0. Solve for x. 2 times 0. Okay. Solve for x. Divide by -5. Now these are easy ones. Okay. Oh, -2. Again, divided by -5 is -2. Here's the trick question. What is the x-intercept? Here's the trick, and it's not really a trick at all. It is a point, okay? It is a point. The x-intercept is a single point. The x value is -2. What's the y value? 0. So when I ask for the x-intercept, it needs to be written -2, 0 in order pair form. That is extremely important. -2, 0. That is the x-intercept. Okay. Y-intercept. 2y minus 5x equals 10. Okay. For y-intercept, across the y-axis, no matter where across the y-axis, it really does not matter. What's the y value? I don't know. What's the x value? The x value is 0 because we went left or right, 0. So on the y-intercept, the x value will always be 0. So let's find the y-intercept. Let's find the y-intercept. Okay. Nope. Because that's going to give me nothing. If I plug in the x-intercept, I'm just going to get -2, 0. That is a solution, but that doesn't help me find the y-intercept. To find the y-intercept, first, what does x equal? Set x equal. Solve for y. Solve for y. Okay. Yeah. It's just the opposite. Set x equal to 0, solve for y. Okay, let's do that. Okay. 2y. 5 times 0. 10. -5 times 0. 0. -2y minus 0 is gone. Okay, 2y equals 10. Divide by 2. Y equals 5. What is the y-intercept? Okay, great. Let's graph. I only have 2 points. That's okay. I don't care. 2 points is fine. 2y minus 5x equals 10. I have 2 points already, right? They're what? 0, 5, -2, 0. Let's graph. Okay. -2, 0. Where? Starting here, which way do I go? Left, 2 spots. The first one is left and right. 0, 5. You go up or down. Up 5. Hey, it's the graph of our line. It's the same graph as before. We're zoomed out a little bit. Huh? Yeah. Oh yeah. It's not so bad. Even if those had been fractions, it would not have been as bad as the other one. Let me show you. Let me show you what I mean by that. That's fine. Mm-hmm. That's fine. Okay. Let's graph the x and y intercept. First, let's do the x intercept. So when we find the x intercept, what do? Make y equal 0. Oh, -9 halves. That's fine. What's the x intercept? -9 halves 0. How about the y intercept? Find that. So we're going to set x equal to 0. Divide by 3. Oh, that's a nice one. 0, 3. Okay, great. So we end up with 2 intercepts: an x-intercept and a y, excuse me, and a y-intercept. X-intercept and a y-intercept. Okay, let's graph. We're going to draw a Cartesian plane. Okay, 0, 3. That's an easy one. -9 halves. Hmm? Hmm? -4.5. -4.5. Okay. Yeah. The nice thing about only graphing 2 points instead of 3 is you don't have to try to make that line go 3 to your 3 crooked points, right? When you only have 2 points, it's a lot easier. But yeah, and even that 9/2 is not that hard to graph when it's on an axis. It's a lot easier to do when it's on an axis than it is when it's out. Okay. Any questions about this, about finding active intercepts and graphing? Two more things that cover in this section. Horizontal and vertical lines. That is equation when you get this. When you're missing an x or a y term. When you get x equals 2. We do not have a y value to go with it. What that means is the y value does not matter. The y value simply does not matter. What is the x equal? What is y equal? Yeah, sure. What's x equal? What is y equal? Doesn't matter. Matters. Yeah. Okay, so what's the x value? 2, 0, 2, 2, 2, 5. Yeah. The y value simply doesn't matter. It's up there somewhere, right? 138. The y value simply does not matter. All that matters is the x value. This is the graph. It's a straight line, vertical line going up and down at x equals 2. Okay. You end up with no y term, just an x equals something as your original equation. And that's x equals whatever x equals. The vertical graph. Or something. Same idea. Y is, does not matter what the x is. Y equals -3. Okay, y is -3. What's the x? Doesn't matter. What's the x? Doesn't matter. But y is -3. The x simply does not matter in this equation. So, 0, -3, 1, -3, -4, -3, doesn't really matter. It's a horizontal line where y equals -3. These only occur when you're missing an x or a y term in your original equation. Okay, let me give you some homework questions. Is this 11:30 already? Wow, okay. That was, yeah, pretty fast, it felt like. Okay. On page Let's just start on page 178 or one. Let's do one through 9. 31. Odd. Okay. Just as I said earlier, it is important that you do the homework so you know what questions to ask. Okay? So you know what questions to ask. Otherwise, you don't know what you need to work on. Okay. Um, yeah, and here's the real problem with this book, right? Isn't the fact that you may have a different edition. It's that Elaine Martin Gay wrote 2 different series of developmental algebras. Yeah. Yeah, Elaine Martin Gay wrote 2 different editions, or 2 different tracks of developmental algebra. And yeah, you got the other one. Both of you, apparently, I guess, did. Yeah, yeah. I think you could probably make it work. Math, right? Um, and I can look at it and tell you what I would work on in those sections. Um, okay. The slope of a line. Okay. Here, that was drawn. Has a slope. He goes up from left to right. Okay. I'm going to draw 2 points. Negative 2, 1. One, 3. Okay. I want to know the slope of this line. I don't know the equation. I don't really care. I want to know the slope of this line. One, 1, 2. 2, and there's run was 3. And that is what slope is. Slope is the rise over run. In the simplest term, is the rise over the run. Don't care. Ooh. I'm just going from one, I'm counting from one, right 3. So positive 3. Now I can go from the other, I can go the other way. Yeah, that's fine. So down 2, left 3. Oh, the negatives cancel, right? Yeah, the negatives are going to cancel, leaving a positive 2/3. The slope is a positive 2/3. If the slope is positive, then the graph went up from left to right. If the slope is positive, the graph went up from left to right. -3, -2, and let's do -2, -1. Okay. This graph is going to have a negative slope. I know it before I ever start. It goes down from left to right. But what is the we're going to go down. One spot. Oh, just -3. Slope is simply -3. Oh, hold on. No, I wrote that down. Okay, it's -3. Sorry. My fault. Okay, yeah, that's -3, +2, right? And then -2, -1 is down below. Okay. But we're just counting. All I'm going to do, I'm plotting the points and counting for now. The larger the number is, the steeper the slope. This one right here is a 3. It has a pretty steep slope. Right here's 2/3, not as steep. I know one's positive and one's negative, but you get the idea. Okay. We can't always graph the points. We can graph the points, but counting them when we graph the points can become I don't know why I drew a line there. But we're just going to go ahead and make this kind of easy. Yeah, we'll just make it easy. Okay. Yeah, if I draw these graphs, I'm going to have trouble with slope. slope is going to be an issue. Okay, mainly because I'm not going. How good am I really going to draw fractions? And then on top of that, how well am I going to count them from one point to another? So we do not rely on the tried through graph it and just count method. We have a formula. And that formula is based on this. How far down you went, how far over you go. Okay? Can anybody tell me what point this right here is? -3, -1. Okay, here's how we are going to do the slope. It is rise over run. But the rise is how far up or down it goes, right? So it is going to be -3 minus 2. Sorry, -1 minus 2. -1 minus 2 is? And this one right here is going to be -3 minus a -2. No, I said that wrong. -2 minus a -3. So this is -2 minus -1 minus -2 is -3. -2 minus a -3, +1. Okay. We are simply subtracting the y values, x values on bottom. Okay. All right. If I give you these two, we are subtracting the y values on top and the x values on bottom. This is the formula. Let me just go ahead and write it. M is the symbol for slope. Don't know why. No, S is a symbol for speed. Is the subtracting the two x values, the two y values on top, and subtracting the two x values on bottom. Okay, it does not matter which one of these is 0.1 and which one is 0.2. Pick one. That is completely irrelevant. Nope, it always works. This will always work. It's necessary if you have fractions because there's no other way to do it well. Call the fractions. It works for big numbers too, right? Once I get up to like 74 and 123, I'm not graphing that and counting points. I'm using a formula. Okay, but we're going to plug in. And I said, I'll set these up so they should work out fine for us, I think. Nope. This is finding a slope. Slope-intercept forms tomorrow. We are just finding a slope. Okay. Y2 is 3/5 minus Y1. Over X2 minus X1. What is 3/5 minus negative 7/5? Those are both negative. They get added together. 10/5. Okay. Okay. 10/5. 1/2 minus 5/2. Negative 4/2. Okay. What is 10/5? What is negative 4/2? Slope. Hey, slope turned out to be -1. Great. That worked out nice. Should have easily been a fraction, right? Okay. Finding slope. It's simply a matter of using a formula. This is the formula. M equals y2 minus y1 over x2 minus x1. Practice doing this. Find the slope line. I'm not going to do slope intercept form today. I'll save that for tomorrow. So tomorrow, we'll do slope intercept form, which is all what 3.3 is all about, slope intercept form, okay? Which is part of the reason I'm going to just go ahead and save it. And 3.4, which is writing the equation of a line. If I give you 2 points, and you can graph it, right? We can graph off just 2 points. But once I have that graph, can I rewrite the equation of a line? We're going to do that tomorrow as well. Okay, let me give you homework from 3.2. We are just going to do 1 through 15 odd. 1 through 15 odd. On page 194, 195.